is going to kind of fill in the gap for us, because up until this point, when we've been using the law of sines, we have to have a triangle that is set up with some given information so that I can get at least one angle and its corresponding side as a pair for one of the ratios in the law of sines. And that's what we were looking for on that example in the homework. We knew that one side was 30 kilometers. We had to find a way to figure out that missing angle so that we could set up the law of sines. So review from yesterday and also from last Thursday, the law of sines can be used for any case, angle, side angle, angle, side. Those first two are really easy because if you know two angles in a triangle, then you automatically know the third angle, right? Using the triangle angle sum theorem, they all add up to 180. So that didn't really create any issues for us. We did talk about yesterday in the law of sines the ambiguous case. That's when instead of getting two of the angles, you get two sides and just one angle, but the angle's not included in the sides. So anytime you show up with side angle, remember that's ambiguous. That's when you need to assume that there are two triangles and do the work to see if there are 0, 1, or 2. But law of cosines is going to fill in the gap for us. It's going to give us ways to solve triangles. So find all the missing sides, all the missing angles. If the triangle gives the information for side, so you know all three sides to start with, how are you going to find an angle? Certainly not with law of sines. So you got to use law of cosines. And then also in the case of side angle side. Okay, we'll be able to find the missing side and then the missing two angles. Now, before we get started, I'm going to do a quick proof for the law of cosines. And the law of cosines is a little bit more involved than the proof that we did, the activity that you did with the law of sines. So I'm not really going to ask you in the future to prove the law of cosines. If you want to copy this into your notes, you may, but I think probably the best thing is for you to see it and be participating in the discussion. And maybe if you want to copy it, go copy it from the textbook or from the video later on today. But I'm going to walk through the proof of the law of cosines so you see where the formula came from. Okay. So to start, I'm going to draw a picture of the coordinate plane. The law of cosines comes very nicely if I draw a triangle on the coordinate plane and assign ordered pairs to that triangle. So I'm going to put one of my ordered pairs at the origin. So this is at 0, 0. I'm going to go ahead and call that vertex A. And then I'm going to put one of my other points at the further to the right on the x-axis. Okay, so I'm going to keep that horizontal. And then somewhere out in the middle, I'm going to put another point, and I'll use these points to draw my triangle. Okay, so there's B and there's C. Using the side lengths, so opposite of angle A is A, opposite of angle B is B, and opposite of angle C is C. I know that this distance from point A to point B is C to the right. So I could call this ordered pair C, 0. Okay, because I'm moving C units to the right. And then for point C, it's a little bit less nice. All I know is I'm going right some units, and then I'm going up some units. So I'm really just going to call that X and Y. Now, the issue with leaving point C as X and Y is that if I write any kind of formula in order to be able to solve for lengths or angles, that formula is going to be in terms of A's, B's, and C's, angles and sides, but also potentially X and Y, which are these coordinates that in a regular geometric shaped triangle, maybe I'm not on the coordinate plane. So what we're going to do is very similar to what you did on the pink sheet with law of sines. We're going to rewrite X and rewrite Y so that they're in terms of the letters A, B's, and C's. Okay? And so in order to do that, I'm going to go ahead and highlight this. I'm going to focus on this right triangle that I formed, okay, with angle A and the sides X, Y, and B. So if I wanted to solve for X, this is the adjacent side to angle A, and I could use X and B, which is the hypotenuse, and I could write an equation that says the cosine of A is equal to X over B. Do you agree with that in the green triangle? Okay? And so then if I solve for x, x is really b times cosine A. So now I'm taking the x and I'm not writing it in terms of ordered pairs, x and y. I can write it in terms of the b's, a's, and c's that I see in the triangle. I could do the same thing for y. When I look at y is now opposite of angle A. And so I would use y and b, opposite and hypotenuse, so I'd be using sine. So I could say something like the sine of angle A is equal to y over b, so y is equal to b sine A. So I can rewrite this ordered pair, b cosine A, comma, b sine A. And now when I look at all three ordered pairs, they're either zeros or they're in terms of A, B, or C, somehow, side or angle. So here's where we start playing around using those coordinates with the law of cosines. Suppose I want to find a side of the triangle. And when I find a side of a triangle, I'm wanting to find the distance of the triangle. Okay? So I'm going to look at side A, okay? And I'm going to use the distance formula. Okay, so think about when you want to use the distance formula, you do the square root of, and you do x minus x squared. Okay? So when I look for the distance of side A, I'm going from this point to this point here. It would be something like b cosine A minus c. Okay? So I can put that in for my distance formula, b cosine A minus c squared, plus, and then I've got to do y minus y. So that would be b sine A minus 0. Squared. We okay with this? Okay. Now, I don't really like having that radical hanging out there while I got to do all this work, so I'm going to eliminate the radical from both sides by squaring both sides, or eliminate the radical from the right side by squaring both sides, which means this is no longer a, this is a squared. And then I'm going to do the work to like multiply these out. For this one, remember I did this when we did the sum and difference formulas. If you expand a minus b squared, it will always come out to be a squared minus 2ab plus b squared. Because your outside and inside terms will be the same. So there will be two of them, a times b. So I'm going to use that to expand this first one. My first term would be a squared, which happens to be the b cosine A, all squared. If I square all of that, I got to square the b and the cosine. So that would be b squared cosine squared A. And then my outside and inside terms would be whatever b times cosine A times c is, but there would be two of them and they would be negative. So it would be minus 2bc times cosine A. I rearranged my multiplication a little bit there. B times c follows a little bit nicer. Cosine A is kind of separate. And then I still have to do plus the b squared, which happens to be that last term of c. It would be negative c times negative c, so it's really going to be plus c squared. So I expanded that. And then over here, b sine A minus 0 is really just b sine A, right? And if I square b sine A, I got to square the b and I got to square the sine. So that's just going to be plus b squared sine squared A. So I'm just doing expansion. I'm just FOILing or distributing, combining like terms. But because I know about that pattern for expanding a binomial that's being squared, that goes a little bit quicker for me. Now, I'm going to do some rearranging of these terms. Two terms I'm going to rearrange real quick are going to be these terms with the b squareds because they're really like terms. Okay, they can be added together. If I were adding b squared terms together, I would just add their coefficients. So I do cosine squared A plus sine squared A, and then that's getting multiplied by b squared. You could also think about it like regrouping them so they're right next to each other and factoring out the b squared from both terms. If I redistribute this, I get the b squared cosine squared, I get the b squared sine squared. What are you noticing about cosine squared A plus sine squared A? That's the Pythagorean identity, and that's just equal to 1. So really, it's going to be 1b squared. Okay. Then I'm going to pick up my c squared. There is no other c squared term, so it's going to be all by itself. And then I'm going to just have to subtract this 2bc, bless you, times cosine A. So when I clean that up, this is your law of cosines. A squared equals b squared plus c squared minus 2bc times cosine A. There is the law of cosines. Now, a couple of things to note, and we're going to rewrite this on the next slide. Notice that if you're trying to find side A, it matches the angle in the cosine, so you do the cosine of angle A at the very end. But then all the other terms that you're using have to be the other two sides. So you use side B and side C in the formula for A. If you're trying to find side B, then the other two sides, A and C, are what you would use in the formula, and you would use the cosine of B at the end. Okay? So here's what you need to put into your notebook. Law of cosines. You can draw a triangle ABC. Okay? It's got to be labeled the same way so that every side opposite an angle has that corresponding letter. And then I'm going to write that very first law of cosines that I have. A squared equals b squared plus c squared minus 2bc times cosine A. Now, I want to make a point. This is times. I'm only putting that dot there so that you can see, like, that's not, like, there's a difference between the c and the cosine. Okay. But that's times. Don't make that a plus. Don't make that a minus. Okay, got another formula. There's one for each. So there's an a squared equals, a b squared equals, and a c squared equals. If I switch it to b squared, then basically all the b's get replaced with a's. So it would be a squared plus c squared minus 2ac times cosine b. Remember, the angle in the law of cosines matches that squared on the other side. And then c squared equals a squared plus b squared minus 2ab times cosine c. Now, I really focus when I'm working with law of cosines and I'm trying to remember the formulas. I really just remember the first one here. That's the one I'm going to remember. And then I just really focus on patterns. Okay, what would change if I'm, instead of finding a squared, what would change if I'm finding b squared? Okay, and vice versa. Now, this is great, these formulas, if you're trying to find a side. Right? You have a squared equals, b squared equals, c squared equals. You do all that work on the other side, and then you're going to have to square root both sides, and you'll have your side length. Okay, so those formulas work really great if you want to find a side. But what if you're using the law of cosines and you want to find an angle? Looking at any one of those lines for the formula, what part of the formula would we like to solve for? The cosine of A, cosine of B, or the cosine of C. So I'm going to do a little bit of algebra work. I'm going to take this first formula, I'm going to put it up here. A squared equals b squared plus c squared minus 2bc times cosine A. And you guys are telling me, if you wanted to have a formula for an angle, you'd really want to get the cosine of A all by itself. You'd want those formulas to look like cosine A equals, cosine B equals, cosine C equals. So how are you going to move those other things to the other side? What would you move first? The b squared and the c squared. Those things are being added with that cosine A term, so we're going to have to subtract them to the other side. So I would subtract b squared and subtract c squared, so I'll get a squared minus b squared minus c squared equals negative 2bc times cosine A. And then again, to try to get the cosine A all by itself, divide by negative 2bc. And then that's basically it, but mathematicians are going to change that formula just a little bit. Instead of having the negative 2bc in the denominator, they're going to let that be positive 2bc, which means up in the numerator we got to change all of the signs. So if you divide by a negative, then your numerator is going to change its signs. It's going to be minus a plus b plus c, and we'll make that a positive. And then when I copy down this formula, the cosine of a equals, I'm going to rearrange that numerator so that the positive ones are first. B squared plus c squared minus a squared. That one used to be positive when we divided by a negative. A squared was the only one that was negative. So we're going to minus it at the end, divided by 2bc. Again, there's a pattern here that you can notice. The cosine of the angle that you're taking is the one that's negative at the end. And then everything else is in terms of b's and c's. So when I do cosine of b, I'm going to start with a squared and c squared as positives and subtract the b squared. And then the denominator always matches the first two, so 2ac. And then I could write my third one. A squared plus b squared minus c squared all over 2ab. So technically you could say there are 6 formulas for the law of cosines. Do I expect you to memorize 6 separate formulas? No. I think you're at a point where you could probably know the first 2 and then work to know your patterns, what's happening in each formula, what changes, and then you can adjust depending on which side or which angle you're trying to find. Now, hopefully, if you were going through some of those formulas, talking about all the a squareds, b squareds, and c squareds, it started to make you think about what? A little bit. B squared, b squared, c squared. A little bit of Pythagorean theorem, and even in fact on this very last one for the side, c squared equals a squared plus b squared minus 2ab times cosine c. But there should be a connection to the Pythagorean theorem because in order to get the law of cosines, I used distance formula, which we've talked about before, is the Pythagorean theorem. Okay, so you continue to use that Pythagorean theorem, it kind of pops up here. Okay, you see it in different ways. Let's look at some examples. Okay, so here's our first example. We got triangle ABC. You can draw it any way you like. Angle B is 81, side C is 19, and side A is 22. Notice that if you're taking your quiz on Thursday and you're looking at this triangle and you love the law of sines, and you use the law of sines for this triangle. You could use the law of sines. What corresponding angle and side do you have? None, right? I only know angle B, and I don't know what side B is. Is there any way for me to know what those other 2 angles are right now? No. If you're looking at this in terms of like what is the given information, I have 2 sides and the angle included between the 2 sides. So this is a case of side angle side. You can also know which tool to use based on what's the given information. So side angle side is one, it can never be solved with law of sines because the given information doesn't give you enough to find any of the missing angles or find any of the missing sides. Okay. So this tells me immediately I'm going to use law of cosines. And when it's side angle side, I usually find my missing side first. So the side that I'd like to find is side B. So I look back at my notes. B squared is equal to A squared plus C squared minus 2AC times cosine of B. And then I just have to plug stuff in. Don't know B squared, but I do know A. A is 22. C is 19. Minus 2 times 22 times 19 times the cosine of 81. So while knowing the formula is long, okay, and you'll need to know it by Thursday, but by knowing the formula, this actually becomes pretty slick. I'm going to pull up my calculator over here. Remember, if for any reason you're changing into radian modes, always make sure you're in degree modes. Again. And I'm just going to type in that whole right side. 22 squared plus 19 squared minus 2 times 22 times 19 times the cosine of 81. I got 714.22. Is that your missing side?
No.
No, what do you have to do? Square root. Remember, we can avoid rounding till the last moment by using our second answer button. So I'm going to do second x squared to get the square root, and then I'm going to do second answer. And that's just going to pop all that 714.22 yada yada right in there, and I get 26.72. I just found the missing side. So it's really not a whole lot of work on your part other than knowing the formula. Okay, the calculator is going to do the majority of that work for you. Now, I want you to think about, if you know this side is 26.72, have a little brainstorm at your tables and talk to the people around you. How could you go about now finding the two missing angles? So angle A or angle C. Brainstorm with your members. There's more than one way to do this, so see what people are thinking. How would you find the angles? You had any ideas? Oh, sorry. It is. These are not squared. So in your formulas, they are 2AC and 2BC. You don't square those numbers. See if that gets you the right answer. Okay, I'm going to interrupt really quickly. What are some ideas for finding the angles? Law of sines. Before I said, could you use the law of sines? The answer was no. Now, can you use the law of sines? Yeah, do you have a corresponding angle inside? Yeah, you've got angle B and side B. So some of you might start saying sine of 81 over 26.72 is equal to, and if you want to find A, sine A over 22, and do the work. Others of you said use what? Not law of sines. Law of cosines. Use those angle formulas, right? If you want to find angle A, do cosine of A is equal to B squared plus C squared minus A squared all over 2 times B times C. So at this point, it's kind of like choose your own adventure. You've got choices. Okay, if you find that missing side, you could use the law of sines. Now, either way you solve, you should get the correct answer. If you use your answer button, 26.72, you'll have a more accurate answer. So you want to attempt using that sometimes, okay, so that you can get better at that. I'm going to do some work for the law of cosine one. In my calculator, I don't have math print, so if I'm going to do all this formula in my calculator all at once, I'm going to need a group of parentheses around my numerator and a group of parentheses around my denominator. So I'm going to use the answer button. I'm going to do answer squared plus 19 squared minus 22 squared, close my parentheses, divide by 2 times my answer times 19. And that gets like 0.582 stuff. But that's what the cosine of A is equal to. So I'd say something like cosine A, if I'm writing some work, cosine A equals 0.5822. And then I've still got to arc cosine both sides if I'm using law of sine or law of cosines. And so I could do second cosine, second answer, and I get 54.4. Now, if I were to do the law of sines over there, I would have to do cross multiplication, 22 times sine of 81, and then divide. I don't have my answer anymore for 26.72, so I'm going to use the rounded value, 26.72. And so I'd come up with something over here that says the sine of A is equal to 0.8132. And then because this is the law of sines, I've still got to arc sine both sides. So I'm going to arc sine the answer there. And I come up with 54.41. Basically the same answer? Yeah. We talked about, like, this answer is probably a little bit more accurate, 54.40. Okay, because I was using the answer button, so I was keeping all those digits from the calculator. I'm not going to take off if you're off in the hundreds. Okay, but be careful with your rounding. Try to avoid rounding if possible. If you know angle A, can you find angle C? Yeah, did anybody do angle C? What is angle C in this example? 44.6. You do 180 minus 81 minus 54.4, which is 44.6 degrees. So now you have all angles, all sides that we're missing. Any questions about that? Remember, you do have an option. You can do law of sines, you can do law of cosines again. You're going to come up with a good answer either way. Okay. Another example that we should look at just real quick is an example of the side, side, side. Okay. So here I have side A is 10, side B is 12, and side C is 8. Your job in this problem is just to find all the missing angles, right? So the law of sines is going to be unhelpful because you only have sides, so you can't pair them up with any angles. So obviously we're going to do law of cosines. There's one thing you need to put in your notes about side, side, side. Okay, add this into your notes, make sure you have this. Find the largest angle first. Work out really nicely with the law of cosines. If you always find the largest angle first, it can either be an acute angle or an obtuse angle. Because in the law of cosines you have a cosine, and at some point you have to do inverse cosine. Remember from chapter 4, inverse cosine on the calculator is going to give us an answer in quadrant 1 or quadrant 2, and that spans 0 to 180 degrees. So if we have an obtuse angle in a triangle, by finding the largest angle first, we'll make sure to get the correct value. Okay. If you don't find the largest angle first and it's obtuse, sometimes things can act a little bit funny and you actually get inaccurate angle measures. So you've always got to find the largest angle first. How will we know which angle is the largest angle? The one across from the largest side. So if B is the longest side, then angle B is the largest angle. So I immediately know I want to start with the cosine of B equals. Cosine of B equals A squared plus C squared minus B squared all over 2 times A times C. Again, remember, if you don't have math print on your graphing calculator, you may need a group of parentheses around the numerator and the denominator to separate that. So I'm going to do parentheses, 10 squared plus 8 squared minus 12 squared. Close my parentheses there, divide by, and then in that multiplication I have to include that in parentheses as well, 2 times 10 times 8. If you didn't include parentheses around the denominator, your calculator would divide by 2 and then start multiplying by 8 and 10, and would get you a number so big you wouldn't be able to take the inverse cosine of it. So make sure that you follow the rules as needed. I get 0.125. And then I just have to inverse cosine. So second cosine, second answer, 82.82. So you now have one angle. This one did not come out to be obtuse, but that's okay. We got 82.82. What could you do to find another angle? You could go back to law of sines or do another law of cosine. Either one would be acceptable. Thank you. Either one is fine. Some of you might just choose to do law of cosines. I think the law of cosines with the angles actually works out pretty smoothly. So I'm then going to find cosine of A. So I'll do 8 squared plus 10 squared minus, 12 squared. Minus 10 squared all over 2 times 8 times 12. Plus 144 minus 100 divided by, what is that, 16 times 12? I get 0.562. And then I've got inverse cosine that. Get 55.77. And then at that point, C would be pretty easy. 180 minus 82.82 minus 55.77. Can anybody get me a number for C? 41.43. And even if you solved a different angle first, if you did law of sines, you should come up with the same angles. Are there any questions about that that we should talk about? Why I did what I did? That blue stuff at the top, that's very important. If I give you side, 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 I'm going to need you to find the largest angle first. Okay, so that's something that you study, that's something that you prepare for. We have one other formula to talk about really quickly, and that's the formula for the area of a triangle. Again. It's called Heron's formula. It's named after somebody. I don't know why this one has a name and the other one doesn't. That's a common question every year. I don't know. I'd have to look it up. There's actually two parts to Heron's formula. So the part that actually calculates the area is this stuff with the square root. So the area is equal to the square root of this large product, S times S minus A times S minus B times S minus C. And like looking at that, the lowercase a, b, and c represent sides of a triangle. So in order to use Heron's formula, it would be a side, side, side case, where you knew all three sides of the triangle, you knew none of the angles, and you wanted to find the area of the triangle. The S that's in the formula is its own separate little piece right here. And this S, this is how you calculate S. You take all three sides of the triangle and add them up, and then divide by 2. What do we call that when you take all three sides of a triangle and add it up? What are you finding? Without dividing by 2, you're finding the perimeter of the triangle, right? When you divide it by 2, you're not necessarily finding the average, because you would divide by 3 if you were adding up 3 things. But this is called semi-perimeter, which is why we use the letter S for it. Semi meaning half, like a semicircle. So you actually have to do the semi-perimeter first. If you know all three sides, add them up, divide by 2, get that half of your perimeter, and then you use that number with all the sides to calculate the area. Again, for people who don't have the math print on their calculator, where it gives you like a square root or it introduces a square root in a parentheses, and I'm not sure, like, I think Casio maybe doesn't bring up a square root, but you should bring one. There may be an extra set of parentheses that you need right there. The TIs will bring up a square root and a parenthesis. And so you start that, S, and then you just open a new parenthesis, but you'll double close at the end if you're working on a TI without that print. If you're doing the Casio, you might have to put in that first parenthesis to make it work. So just really quickly, here's an example. Find the area of the triangle if I give you 3 sides. A is 15, B is 8, and C is 22. Well, the first thing I'm going to do is find semi-perimeter if I want to use Heron's formula. That gives me like 45 divided by 2, which is 22.5 for S. And then the area is 22.5 times 22.5 minus 15 times 22.5 minus 8 times 22.5 minus 22. And that's just basically a calculation I need to do. You'll always have an area there, so if your calculator is giving you an imaginary answer, an answer with I, or telling you that you're getting a complex answer, I would guess you either calculated semi-perimeter wrong, or you put them in the S minus A, S minus B, S minus C in the opposite order, so that you got negatives instead of positives. But let's see. The semi-perimeter will always be longer than the sides, so you always get positives. Okay, and if you pull up your calculator and type that in, I can't remember what my calculator will do here. Okay, see, mine has the math print now, so I can do 22.5, and then I can keep going, and it's going to be underneath. If I didn't, I'd need another set of parentheses right there. I get 34.98 units squared. Okay? So, think again. Do your homework tonight. Practice the different types of law of cosines. You know how Ethan always saying, we can go back to law of sines, we could go back to law of sines. That's cool. It's true. You can choose your own adventure at that moment. But you do have to know law of cosines for Thursday. So if you kind of push yourself and maybe use law of cosines, that'll get you some extra practice with those formulas. We'll go over questions. We can take a second look at the word problem 53 if we need to tomorrow. And tomorrow will be review, and Thursday will be your quiz.